The so-called new space phenomenon is helping in reducing the costs required to access space, and the miniaturization of technology has made it possible to perform interesting experiments with small form factors. In recent decades, developing countries have been given the possibility to access space, including my home country, Mexico, in which a second space era is booming. So in this video, I will present some of the most recent Mexican space missions. Are you ready? Comenzamos. The Aztecsat-1 project was a collaboration between NASA and the Mexican Space Agency, whose kickoff was in 2017. NASA defined the mission as the communication of the Aztecsat-1 with the existing constellation of global star satellites in low Earth orbit in order to obtain science data through that infrastructure and thus not relying only on the ground station connections, which is, prone to errors. The Mexican Space Agency in turn delegated the work of developing the satellite to the University of UPAEP, which stands for Universidad Popular Autónoma del Estado de Puebla. So the Aztecsat-1 is a one-unit CubeSat, so it's 10 centimeters on each side, and it's composed of an aluminum structure, an electrical power system with two lithium-ion batteries, and onboard computer, which is based on the AVR 32-bit architecture. It also has an attitude determination and control system, which uses an inertial measurement unit, sun sensors, and magnetorquers, which are incorporated on three orthogonal solar panels. It also has a radio transceiver with an antenna for communication in the ultra high frequency range, and also the specific payload board. So the main component of the payload board is a Stinger, is a modem from Globalstar, which is a system that incorporates the radio transmitter, a GPS receiver, and a patch antenna all in a single integrated unit. The payload board also contains a 32-bit Cortex M3 ARM microcontroller used to command the Stinger and a PC104 connector to interface with the rest of the CubeSat. The communication between the Aztecsat-1 and the global star satellites occur at a frequency within the L-band, something around 1600 MHz, and the UHF transceiver used for telemetry and telecommand operated with a downlink frequency of 437 MHz and an uplink frequency of 435 MHz. In order to ensure that the satellite would survive its journey towards the International Space Station and also survive to the space conditions, some special tests, which are called environmental tests, were conducted on the flight models. So the Aztecsat-1 was subject to vibration testing and thermal vacuum tests. For small payloads, the test should cover full from 20 to 2000 Hz frequency range for random vibrations. And if a random vibration test is appropriate, then the project to be tested should obtain the spacecraft's random vibration environment from the launch provider, from the rocket per se. So random vibrations require that the nanosatellite complies with random acceleration levels. Vibrations are applied to the base of the adapter in which the CubeSat is hosted in each of the three orthogonal axes, one of which is obviously like parallel to the thrust axis. For Aztecsat-1, vibration testing used the SpaceX launch vehicle profiles. So the spacecraft must perform satisfactorily within vacuum and thermal mission limits per se defined by its final orbit. Aztecsat-1 is intended for LEO with expected temperatures from minus 20 to 60 degrees Celsius. However, the thermal vacuum test was conducted in the range from minus 15 to 60 degrees due to the small size of the satellite. Both stabilized and transitional conditions were produced, and these conditions induced stresses intended to uncover incipient problems. Aztecsat-1 was placed in the vacuum chamber and decreased to a hard vacuum, which is at least 3 times 10 to the minus 4 torr. Temperature sensors were used for control and monitoring, and once in vacuum, cryostasis chamber was cycled down to minus 15 degrees Celsius and it remained there for 270 minutes. And then the chamber was cycled up to 60 degrees and held there for again 270 minutes. We repeated the cycle one more time, and a functional check was completed after all of the runs to ensure that the satellite was still functioning. The CubeSat was launched as part of the NASA's CubeSat launch initiative ELANA 25B on board the Falcon 9 rocket on December 5th, 2019 to the International Space Station, and it remained there until it was deployed into space on February 19, 2020 using the NanoRacks CubeSat deployer. The altitude of the CubeSat was around 400 kilometers with an inclination of 51.6 degrees, namely because of being deployed from the ISS. And now, the global star constellation consists of 48 satellites placed at an altitude of 1,414 kilometers. They are flying on 8 orbital planes of 6 satellites each, inclined at 52 degrees, to provide service on Earth from 70 degrees north to 70 degrees south latitude. And the ground station network consists of 24 ground stations distributed worldwide, allowing a footprint connection for over 120 countries around the globe. The Stinger modem from Globalstar offers 5 different packet lengths to be transmitted. So it can transmit packets of 9 bytes, 18 bytes, 36 bytes, 72 bytes, and 144 bytes. All of them were tested during the mission. The message sent both through the UHF and the Globalstar constellation was basically the housekeeping data of the satellite, which was in total 157 bytes. And from the analysis of the messages sent through the Globalstar constellation, it could be observed that the configuration of the biggest amount, which is 144 bytes per packet, has the biggest success rate. In this context, success rate refers to the relationship between the received messages and the successfully decoded messages. And this happened because this housekeeping data could be reassembled more easily in this case compared to using only 9 byte packets, like many 9 byte packets, in which reconstruction of the housekeeping data, well, was not even feasible. The SXZ-1 mission could therefore show that the Globalstar constellation is a feasible inter-satellite link for CubeSat missions. Now there's a second project going on, the follow-up project called the SXZ-2 or SXZ constellation. And the mission is to monitor marine fauna and will employ a constellation of at least 4 nanosatellites in low Earth orbit as well. The mission concept review stage and the system requirements review phase are already approved. So now the project is working on what is going to be the preliminary design phase. And it will most likely include the Agila board, which was, as described, the payload used for SXZ-1. Colmena is the first Mexican mission to the moon, developed by the Universidad Nacional Autónoma de México, UNAM. This mission consists of developing mini rovers that can communicate between them and autonomously navigate on the lunar surface. The scientific goal is to have each of these mini rovers measure the environmental parameters and the local magnetic field surrounding them in order to characterize the dusty plasma located at a layer between 20 to 30 centimeters over the lunar surface. This has like mining purposes and lunar economy in mind. All the gathered data shall be collected and sent to the ground through the lunar lander called Peregrine, which is owned by the company Astrobotic. One characteristic of the work philosophy of developing mini rovers is being low cost, small, and simple, such that every mini rover is easily replaceable in case something wrong happens to one of the units. Thanks to this, a total of 5 units can travel at a time inside the lunar vehicle, the Peregrine. Each of these mini rovers is 12 centimeters in diameter, 5 centimeters in height, and weighs only around 60 grams. The mechanical structure is made out of nylon, which is pretty common. The manufacturing process that was used is called additive manufacturing. They actually used 3D printers, and a total of 6 different chassis versions were carried out in order to address challenges as they appeared, being the survival, obviously, to the lunar environment and the total mass among the most important challenges to solve. Different materials were taken into consideration, like Ultem 9085, nylon, which is reinforced with carbon fiber, ABS, and just simple nylon. And after many experiments and analysis, nylon was chosen to be the best one. The electronics design of each robot unit includes a solar power system, which is a solar panel, emergency power system, which consists of batteries, an onboard computer, telecommunication system, sensors for measuring the magnetic field, sensors for measuring distance or range to other objects, currents, voltages, and also accelerometer, gyroscope, and magnetometer. All of this circuitry is hosted on a single PCB and attached to this nylon structure. Colmena was launched on January 8, 2024 from Cape Canaveral in the United States on board the Vulcan Centaur rocket from the company ULA. The robots and the system that deploys the robots on the lunar surface traveled inside this peregrine spacecraft, and the spacecraft detached itself from the rocket successfully. However, a problem related to fuel leakage prevented the lunar landing, and the Colmena systems could only test their correct functionality for a deep space distance of 385,000 kilometers away from the Earth. There's already a follow-up mission on schedule, which is planned to launch on 2027, and it will try to now make the scientific measurements of the dusty plasma on the surface of the moon around the mini rovers and this year. Hopefully, this mission will have the chance to now reach the moon and be successful. Shiva 1 is a Earth observation CubeSat with the mission of segmenting the Mexican volcanic ash plumes by using convolutional neural networks, mainly targeting SegNet and UNet, which have been used for volcanology. This project won the sixth round of the CubeCube 2021 competition managed by the Japan Aerospace Exploration Agency, or JAXA, and the United Nations Office for Outer Space Affairs, UNOOSA. The concept of operations is as shown in the image. First of all, the CubeSat shall reach the International Space Station such that it can be attached into the Cubo deployer, developed by the JAXA. When the JAXA confirms, the Shiva 1 will be deployed into space and it should remain silent for 40 minutes. This time window is a safety feature that makes sure that no deployables or communications from the deployed CubeSat will harm or interfere with other elements when close to the ISS. After this 40-minute window, the antenna deployment will follow and the nominal operation shall begin, uh, obviously as long as the battery's state of charge permits it. When the satellite is above Mexican territory, it shall point its hyperspectral camera to take pictures of the craters to further analyze the images with the convolutional neural network algorithms. It is planned to have UHF and global star communication in order to transmit this information as occurred with the Aztecsat 1. And regarding the payload, which is the hyperspectral camera, it can take two-dimensional images with information in different frequency bands. Of special interest for detection of volcanic gases is the infrared range. The images shall be passed through classification algorithms in order to only keep the images that contain volcanic gas information. Should there be any potential risk to the Mexican population due to volcanic activity, an emergency alert will be triggered. The satellite is scheduled to launch this year, 2025, with specific date still to be defined. As we have reviewed, recent Mexican space missions have been possible due to the availability of commercial off-the-shelf components, besides well-defined standards as is the case of the CubeSats. In special regard to the Colmena mission, it has been a very ambitious project which was made possible by a well-crafted analysis of components and many iterations, leading to a significant reduction of mini rover weight. Moving apart from the technical side, also crucial are the international agreements and efforts that have made it possible to share technical developments and provide launch opportunities. I hope you have enjoyed this video. Thanks for watching and have a great day.